So today we're going to deal with probably, as I was like reviewing slides yesterday and this morning, thinking that, yeah, this is a hard day. This is a heavy lift because today we're going to be dealing with the subject of climate change. And I feel like there's a lot that I have to front load about how climate change is happening to this discussion before we can even really address food and food's relationship to climate change. And so I'm a little bit worried that it's light on the food systems, but you are going to have an opportunity to see some interesting videos and read an article or two. And then you're going to do a deep dive later today to explore how climate change has impacted the production of a particular food source or a particular food like coffee or chocolate or wine or cheese or beer. And so, yeah, we're going to have a bit more time to explore that in depth through the Canvas course. So let's get started. Here's our agenda today. We're going to go through three big topics. One is, what is climate change and why should you care? The next is the impacts, looking at the impacts of climate change. We're going to do this by looking at the impacts globally. So just the general, how is climate change impacting the planet? We're going to look at what it means for the United States, how climate has changed in the United States. And then we're going to take a look at 2 or 3 specific Florida issues. And I was really surprised to see how different the experience, and I knew this would be the case, but I was still shocked how different the experience of climate change is for you in Florida versus us here in Arizona. And that is a theme that you'll pick up on through this today's session. And then the food story is about locusts. You think you know what a locust is, you're probably wrong. It's a fascinating story though. So, all right, so let's talk about it. What is climate change and why should you care? And so one of the things that I think, if I address or talk to climate change with folks, one of the questions that often comes up is this one. You know, what's the difference between climate change and global warming? It's not entirely clear in most people's minds, you know, what the relationship is between these terms. And one of the things that I've come across in political reporting about climate change and global warming is sort of like the suspicion that there's like a political motive to using one term or another. And that always struck me as weird because I was studying environmental science about the time that these terms were being kind of worked out. So back in the 1990s and 2000s. So this is generally the consensus of how these terms are used. So global warming is increasing temperatures worldwide. Climate change is the long-term disruption of local weather patterns. Both of them are intricately related. We can't separate them out. And so there's a tendency to use them interchangeably. But very early on in the discussion of global warming, which was the issue that was being addressed scientifically in the late 80s and early 90s, global warming was the preferred term. And so this graph shows you the number of scientific publications that use both of these terms, global warming in red, climate change in blue. And through the 90s and most of the, up even until the late 2000, approaching 2010, global warming was far more represented in scientific literature. And then around 2005 or so, we saw this real increase in using climate change. And I read as a student in environmental science, I read, you know, one of the first papers, I think it was from 1985 or 1990, that advocated for using the term climate change instead of global warming because global warming was merely describing the increase in temperature and climate change was more relevant because of the way that it impacted locations around the globe. So global warming is what's happening, you know, the general trend in terms of global temperatures increasing. Climate change has this very like localized, chaotic feel. So what we're going to see through this discussion is that climate change is experienced differently by all kinds of different communities across the globe. And no two places experience climate change in precisely the same way. So let's talk about the causes, the mechanisms you're probably already familiar with, given the quality of your discussion of climate change versus global warming, that there's this idea that we are putting greenhouse gases into the atmosphere through combustion. There's been a movement recently to, particularly when talking with students, K-12 students, to shift from calling greenhouse gases, saying greenhouse gases, to heat trapping gases. And that is because communicating science needs to be clear and effective. And when you say greenhouse gases, that's relevant to people who are familiar with greenhouses, but not necessarily young people or people who just have never seen a greenhouse or experienced what it's like to be inside a greenhouse. So definitely a shift in recent years to change to using the terms heat trapping gases. But it's very difficult for me to do. I've been saying greenhouse gases since high school, essentially. But as you can see through this graph, we're putting those heat trapping gases into the environment, and energy from the sun is reaching the surface of our planet, and it becomes trapped. And so it becomes increasingly warm on the surface of the planet as the result of those greenhouse or heat trapping gases. And so how many different kinds of greenhouse gases are there? There's dozens and dozens. This is a very incomplete list. The graphic on the left shows you the global warming potential. So carbon dioxide is the one that we hear most about, but it's relatively mild in terms of its ability to warm the atmosphere, to warm the planet. And then we have these others that are also produced by humans. Methane is an important one, nitrous oxide another, and then fluorinated gases. These are the things that are used in refrigerants. So remember the ozone hole discussion that we had a couple days back? We switched to fluorinated gases for our refrigerants because they have a less serious impact on ozone, but they are incredibly effective warming gases. They trap a bunch of heat in the atmosphere. The graphic on the right shows us the percentage of those greenhouse gases that are human caused through our emissions. And so you can see the reason we worry about carbon dioxide, even though it's relatively moderate in terms of its ability to warm, is that it's a huge portion of our emissions. Most of our emissions are carbon dioxide, followed by methane, followed by nitrous oxide, and then only 2% of those fluorinated gases. And we really need to address all of these together. The ones that we are most interested in, probably as industrial societies, are carbon dioxide and methane, but nitrous oxide is also a problem. What have they done? So this graph shows us how atmospheric carbon dioxide has increased since 1880. That's the gray line in the middle of the graph. And then the blue and red lines, those are the differences in the average temperature from the 20th century. So what you're seeing here is a way of displaying the data of heat increases using the average temperature in the 20th century as a baseline. So that 0.0 on the left axis there, that is the average temperature from the 1900s. And as we've gone through our industrial revolution and started to pump more CO2 and other greenhouse gases into the atmosphere, you can see that the departure year over year shows that the average temperature per year has increased compared to that 20th century baseline. So that's bad, right? We're seeing a pretty significant increase in temperature just in the past 60 years or so. And then what does this look like globally? This is 2019 data. This gets updated not quite every year, but frequently by NASA and other groups that monitor temperature globally. And what you can see is that, essentially since 1979, we've had a huge increase in temperatures, most of that localized in the Arctic regions. But you can see in these reddish areas how much temperature has increased since 1979 to 2019. So that's the general picture, right? The global warming picture, things getting warmer.